So in this example, we've got the Smith family that took a canoe 10 miles down the Au River, and it took them 1.25 hours. They had some lunch, and then it took them 4 hours to return. And we're supposed to find the rate of the current. So let's kind of see what's going on here. So we're starting at some location here. We're going to go for, it says 10 miles. And then we're going to have lunch here. Those 10 miles took us 1.25 hours. Now after lunch, we're going to go back to where we started from. It's going to take us 4 hours. Now in looking at this picture, the distance didn't change. The distance is 10 miles in each case. So the distance doesn't change, just the time. And the time makes sense that you're going downriver, you're going fast. If you got to fight the current the whole way back, you're going to be really tired and it's going to take a long time. Now let's try to organize our information in a dirt box. So we got D equals R times T. And we need to organize each of these quantities that are involved. Now in this case, our two rows are going to be with the current and against the current. Now as we said, in each way, the distance stayed the same. The distance was 10 miles. The time is straight up given to us. So these are numbers that we can just plug in. So with the current, it took us 1.25 hours. Against the current, it took us 4 hours. Now let's talk about the rate. So as we talked about in the intro to this example, we know that when you're going with the current, your speed is your speed in still water in this case, plus the speed of the current. And when you're going against, then you're going to take your speed in still water minus the speed of the current. Please write this out in words. It's really going to help you understand what's going on in your problem and not just throwing variables in there. Now we can see what our variables need to be. One of our variables needs to be our speed in still water. So the speed that we're trying to paddle if there was no current at all. And y can be the speed of the current. Again, writing this out in words. And what this tells us is our speed when we're going with the current is x plus y, and against the current our speed is x minus y. And this then gives us two equations. 10 equals 1.25 times x plus y, and 10 equals 4 times x minus y. We need to solve this system of linear equations in order to get our answer. Now, here's the nifty thing. We don't actually need to solve the entire system. We're being asked to find the rate of the current. That's our y value. We're really just being asked what's y. So as I come back to this problem and I want to solve it, the first thing that I would look at is to say, if I could ignore those pieces there, this problem would be really easy to solve by the addition method. Now I can't just get rid of them, but what I could do is divide both sides by 1.25, divide both sides of the second equation by 4. In doing so, let me get my calculator out just to make sure. Pretty sure I can do these ones in my head, but I don't like to make mistakes, especially when I'm recording a video. So we're going to go ahead and do 10 divided by 1.25. And that gets us 8 for this guy. We're left with the x plus y. Now for the divide by 4 piece, we have 10 divide by 4 gets us 2.5. And that leaves us with just the x minus y. Now we could go ahead and use the addition method right here, but what variable would that eliminate? The y's. And what variable am I trying to find? The y. So let's not eliminate the y's, let's eliminate the x's. So let's multiply this guy by -1, and if you saw ahead one step at that, you could have just divided by -4 in the first place rather than +4, but that's all right. That's going to get us -2.5 there. We're going to get -x and +y now. So that when I use the addition method, I'm going to get 5.5 equals x minus x is 0, but y plus y is 2y. Don't forget that this is the addition method. I get a lot of people that forget the 2 here. They forget that we're saying y plus y. So now to solve for y, we divide both sides by 2, and we get 2.75 equals y. If we come back up to the original question, the question was find the rate of the current. Our answer for y does answer that question. So 2.75 miles per hour is the speed of the current. And then to think about whether that answer makes sense or not, we can think about the fact that paddling a boat is similar to a walk or a jog to the point that 5 miles an hour makes sense. The current needs to be less than that because we're going to be able to fight against it. So this answer does make sense that we have a current of 2.75 miles per hour.